like I talked about in the opener, if you have a quadratic equations make parabolas. And you can have a parabola that crosses the x-axis one time. You could have a parabola that crosses the x-axis two times, okay? Or you could have a parabola that crosses the x-axis not at all, okay? So this is when you have one solution. This is when you have two solutions. Where it crosses the x-axis is also known as a solution, okay? Two solutions, and this is no real solutions. But you do have complex solutions, and so we'll talk about those, okay? But it turns out you can tell what type of solution you have by this thing that is part of the quadratic formula. B squared minus 4ac. And this thing has a name, because this is a thing inside the square root thing, right? In the quadratic formula. This thing has a name, and it's called the discriminant, okay? Because it kind of discriminates. Well, it tells you what type, how many, and what type of solutions you're going to have. So rather than go through the whole thing and say, oh, I solved this using quadratic formula, and I turned out that this thing, the thing inside is a negative number, therefore I have complex solutions, okay? You could just plug into b squared minus 4ac, and you can tell pretty quickly how many solutions it has, okay? So if b squared, so here's some rules. If b squared minus 4ac is greater than 0, how many solutions do you think I'm going to have? If b squared minus 4ac is greater than 0. Two solutions, okay? Two solutions. Two real solutions. Two real solutions, okay? And then kind of a subset of that, so if I were to write like an A here, okay? B squared minus 4ac is a perfect square. Perfect square. Then you have two rational solutions. Rational, oops, that's two words. Two rational solutions. Rational means that they can be expressed as an integer or a fraction. Exactly. Okay? Okay? B, okay, if b squared minus 4ac is not a perfect square, then you have two irrational solutions. And they are conjugates. They are conjugates of each other, meaning, so conjugates, irrational, okay? Going to look like this: 2 plus square root of 2 minus square root of 3, and 2 plus square root of 3. So if b squared minus 4ac is not a perfect square, then you're going to have two things that look like this, or you can have another set. You might have square root of 7 and negative square root of 7, okay? But over here, you're going to have two rational solutions like fractions or whole numbers, and they could be plus or minus, okay? The next thing, the situation 2, if b squared minus 4ac is equal to 0, like we just found, how many solutions do I have? Like in the opener, you have one rational solution. And again, rational means it could be expressed as a fraction or an integer. one rational solution. And the third case is if b squared minus 4ac is less than 0, then what kind of solutions do I have? You have two imaginary solutions, okay? And they're complex conjugates of each other. Can I go down? Complex conjugates, as in, whoops, that's not a very good view, is it? Complex conjugates, as in, for example, 2 plus 3i. What's the complex conjugate to 2 plus 3i? 2 minus 3i, okay? So if you have a 2 plus 3i, you're also going to have a 2 minus 3i. If you have a square root of 3 as a root, what else are you going to have? If you have a square root of 3, what else do you have to have? A negative square root of 3. So square roots always come in pairs, as do i's, things containing i's. They always come in pairs, so you're always going to have 2 of them. All right, so we'll do some practice. Okay? You ready? Ready. Okay? So, so let's look at 4x squared. Let's change colors. 4x squared minus plus 8x minus 5 equals 0. Okay? How many and what type of solutions? So it's b squared. Ian, what's b squared? What's b squared? What's b? What's 8 squared? 64 minus 4 times what's a? Ian? What's c? Negative 5. Okay? So 64 minus 4 times, I go this way, 4 times negative 5 is negative 20, times negative 4 gives you positive 80. You get 144. Is that a perfect square? Good. Can I take the square root of that? So looking at these rules, how many solutions am I going to have? One solution, right? Because this is a perfect square. So you have, if b squared minus 4ac is a perfect square, then you're going to have more than, you're going to have two, not one, you said one, right? You have 2 rational solutions, okay? 2 rational solutions. We're not going to find them for right now. Questions on that? Because it's a perfect square. Okay, let's try another one. 3x squared plus 5x. You try, okay? You try on your paper, not on your whiteboards. You try. Where is that one? 3x squared minus or plus 5 equals negative 7x. All you're trying to do is tell me how many solutions you have and what type. Okay? Give that a shot. Whoops, I can't see it. I gotta pause. Stop recording. Okay? So that tells you there's 2 imaginary solutions. Okay? Solutions. Okay. Next one, we're going to try a couple more you tries. How about x squared minus 5x, x squared minus 5x, x squared minus 5x plus 3 equals 0. Okay? How many? And how many? And what type of solutions? Tell me the answer, I give you a bonus point. Of solutions. Okay? Ready? Try. Ready? Try. What's my timer thing? Oh, I keep doing this. I'm looking for the timer here. Okay?
25 minus 12.
B squared minus 4AC is equal to 25 minus 12, which is equal to 13. I cannot, that's not a perfect square. So because it's not a perfect square, you're going to have two irrational solutions, meaning they're going to have two irrational solutions. Meaning they're going to have square roots in the answer. We're not finding the answers right now. We're just telling you how many they have. Okay? Last kind of practice one. What if I had? You try. 3x. No, that's the same one. 4x squared. 4x squared minus 12x plus 9 equals 0. How many, so for this question, you're answering the same question. How many and what type of solutions? Ready, set. You have b squared minus 4ac. b squared minus 4ac is equal to 144 minus 4 times 4ac, which also is equal to 144, right? And you get 144 minus 144, which equals 0, which means you have one rational solution. Because when I add or subtract 0, it doesn't matter if I add or subtract 0. I'm only going to have one answer. Okay? So now we're going to go backwards. You're not going to like this. No, you might like it. Okay? So finding an equation from the solutions. Okay? So let me just finding equations from the solutions. It starts off easy, then it gets a little bit harder. So if negative 2 and 5 are solutions to a quadratic equation, find an equation with those solutions. Does anyone know how to do that? So remember when we factored and we got x here and x here, right? And we said it equal to 0, and we said either this is equal to 0 or that is equal to 0. Okay? If one of the solutions was negative 2, what would have to be over here? Oh, very good, Will. That's right. Okay? Plus 2. If one of the solutions were positive 5, what would have to be over here? Negative 5. Okay? Now, in this case, they want you to, and they'll usually say in standard form, so they'll want you to FOIL this out and get x squared plus 2x minus 5x minus 10 equals 0. Combine your like terms and you get x squared minus 3x minus 10 equals 0. There's more than one equation with those as its solutions. Because I could put a negative sign in front of here. I would still have the solutions. I could put a negative 4 in front of there. I'd still have the same solution. All that does is when I'm graphing the parabola, we'll talk about, it stretches it or flips it, but it still goes through the same spot. So I could have, like if these are solutions, -2 and 5, I could have a parabola that looks like this going through there. I could have a parabola that looks like this going through there, right? I could have a parabola that looks like this going through those same 2 points, okay? So there's infinitely many solutions, but one of them, and the simplest one, is this right there. Get that? No? No? You'll get it as it gets printed. Okay, gets more complicated though. What if I had, it always gets more complicated. What if I knew that 4 and 2/3 are solutions? Find the equation. So what would be one factor? What would be one factor? X minus 4. What would be the other factor? X minus 2/3 equals 0. But if I FOIL this out, I don't want to try to multiply 2/3 by everything. So you know what I said? Like I could put any number in front here and it'd still have those solutions. What would be a nice number to put in front to make that 2/3 go away? 3. You could put 2/3, but 3 would be easier. Because if I put a 3 here, right, I could just put a 3 right here. And I get x minus 4 times 3x. What happens when I multiply 3 times -2/3? What do I get? -2, just like that. And then I could FOIL it out, and I get 3x squared minus 12x minus 2x plus 8 equals 0, or 3x squared minus 14x plus 8 equals 0. You understand what I just did? Because when I multiply through by 3, I don't have to multiply both terms by 3. I just multiply this term by 3 to make that fraction go. Yeah? Yes?
Why are you allowed to multiply with 3?
Because you're just looking for an equation with those things as solutions, right? So if I were to graph this, yes, it goes through. See, if I solve this, I still get x equals 2/3, right? It would have the same solution. Right? If I set this equal to 0, I get x equals 2/3, and here I get x equals 4. But I just multiplied through by 3 to make it look nicer. Now, if I were to graph this, it goes through 2/3 and 4. And so, like what the first equation might look like is like that. But if I multiply that equation by 3, it stretches everything. Whoops, not including my box up there. If I multiply everything by 3, it just makes the graph go down further and kind of do like that, makes it steeper, but it still goes through the same points. Okay? So we'll talk more about the graphs later on, but this equation would look more like this one, and this equation will look more like that one, but it still has the same solution. See? So it goes through the same points. Because they're just asking for an equation. Yes, Sophie?
Why do you make it negative?
Where did I make it negative? Because it's the opposite, right? Remember the zero product property? If I draw my little squiggly line, right? And I have to, what makes this equal to 0? X equals 4 makes this equal to 0. What makes this equal to 0? X equals 2/3 makes this equal to 0, right? Okay. So now you're going to hate this. So you've hated it all the way. No, you won't hate it. Okay. What if I have, this is where it gets a little tricky. What if I know that 3√2 and -3√2 are solutions, okay? Are solutions. Find the equation. The equation of a parabola, okay? With those as solutions. Okay? So you do the same thing. X minus 3√2 times x what? What's minus minus? Plus 3 root 2. Okay? You FOIL. You get x squared. This term, what happens to this term and this term right there? Those disappear, right? Those disappear. And you end up with negative, this times this, what's negative 3 times positive 3? Negative 9. What's root of 2 times root of 2? What's root of 4? 2. And so you go, that's equal to x squared minus 18 equals 0. That is the equation of a parabola that would have these two things as its solutions. You understand? What if I had eyes? This is the hardest one, and then we'll be done. Okay? What if I had eyes? Okay? So, oh, I have eyes. Hey, Kate.
What?
What did you just say?
Talking to Hayes about this.
Did you hear about the guy who's walking around with square roots of -1 on the back of his head?
No.
Yeah. He had eyes in the back of his head. I just made that one up. Okay. Okay. What if? Okay, so here's where it gets tricky. Okay. What if 5 plus 2i, last one, and 5 minus 2i are solutions? Okay. Solutions. Find an equation. A quadratic with those as solutions. So it's the same process, okay? You have x minus, you have to put this in parentheses, 5 plus 2i. Like this, boom, boom, times x minus, in other parentheses, 5 minus 2i. You guys understand why I wrote it like that? If these are solutions, you subtract them, okay, to find the equation. Now I need to multiply that all together, which can be pretty messy. So what I do first is I go x minus 5 minus 2i. I distribute through the negative side in this one, okay? And what I do here, I distribute through the negative sign, minus 5 plus 2i. And then I have to multiply those two things together, okay? The best way to do that is by making one of those boxes. Oh, that's a triangle. Let's make a box, okay? Box, draw some lines. We're impressing the interpreter with my high-tech technology over here, okay? So I'm going to make some lines here, and here, and here, and here, okay? And then I'm going to put these numbers, x minus 5 minus 2i, and x minus 5 plus 2i, okay? And the best thing to do is this, because I've done this before and I always end up making mistakes. So when you're multiplying three terms together, the best way to do it is like this. What? What's x times x? What goes here? Negative 5x. What goes here? This is kind of a weird one, but what goes here? Minus 2, we call it 2xi. Okay? What goes here? Minus 5x. What goes here? 25, right? Negative 5 times 5. What goes here? Plus 10i. What goes down here? 2xi again, right? What goes here? Negative 10i. Whoops, not x. Yeah, that was right. Negative 10i. And what goes here? Negative 4i squared. Now watch. Look. Look what happens. What could I cross out? See, I have a plus 10i there and a minus 10i there. Those go away. See, I have a minus 2xi and a plus 2xi here. Yeah?
Minus 5.
So altogether I have an x squared. I have how many x's altogether? Negative 10x. I have a 25. And then I have this minus 4i squared. But what's minus 4i squared equal to?
4.
That's equal to minus 4 times I squared, remember, was negative 1. So that makes plus 4, right? So altogether I have x squared minus 10x plus 4 equals 0. Would be plus 4, plus 29, I'm sorry. Okay? 25 plus 4 is 29, right? Where'd my thing go? Plus 29 equals 0. So if you see one like this, first rewrite it like this, then distribute, then make a box, then combine all your terms. And I think you only have one of these, okay? Homework. I have a bookwork assignment, but I'm going to give you a choice, okay? The bookwork assignment is pretty long, about 20 problems. I'll make the Math Excel assignment about 8 problems. So you guys can choose, okay? So I'm going to change it so that you can have the